Alright, so this is problem number 3 for the extra credit of exam 3, and it is a problem from the book, and it reads as follows. Methanol is manufactured industrially by the reaction, and then they give us the reaction of carbon monoxide plus hydrogen give us our methanol. And then it says Kc for the reaction, the equilibrium constant for the reaction is 10.5 at 22 degrees Celsius. What is the value of Kp at this temperature? So before anything, we must remember our expression or our equation that relates Kp, the equilibrium constant, in relationship to partial pressure, to the Kc, the equilibrium constant in relationship to concentration, and that will be Kp is equal to Kc times 0.0821, or the constant R, and then times temperature to the power of the change in moles. Alright, so now I've just set up the information that they've given us. They've given us that our temperature is 220 degrees Celsius. However, when we are using it in our equation over here, it can't be in Celsius, it has to be in Kelvin. Therefore, to convert our Celsius into Kelvin, we must add 273 Kelvin, and then in total it's going to give us 493 Kelvin for temperature. And then for our moles is going to be the number of the moles of our products minus the moles of our reactants. And we see over here in our equation that I rewrote that in the moles of our reactants we have 1 mole of carbon monoxide and we have 2 moles of hydrogen, and on the products we have 1 mole of methanol. So therefore our change in moles is going to be 1 minus 3, which is going to give us -2. So our change in moles is -2, and then our temperature is 493 Kelvin. And now all we have left to do is just plug it in and solve for Kp. But also they give us that our Kc, our equilibrium constant, in relationship to concentration is 10.5. Alright, so now all we have left to do is just really quickly, let me do plug in what we're given into our equation in order to solve for our equilibrium constant in relationship to our pressure. So it's going to be the Kc 10.5 times 0.0821, sorry about that, which is our gas constant R, times our temperature in Kelvin, which is 493 Kelvin, to the -2 power. And then we plug that into our calculator and it gives us 6.41 times 10 to the -3. Thank you.